आज हमने पिछले कुछ लेक्चर्स में हमने ये देखा है कि अम, कि कंप्यूटिंग प्रोबेबिलिटी वाया हमने ये देखा था कि कंप्यूटिंग प्रोबेबिलिटी वाया काउंटिंग डज नॉट वर्क फॉर it does not work for spaces that are not simple, sample spaces जो simple नहीं है. नॉन सिंपल सैम्पल स्पेसेस के लिए काउंटिंग वाला मेथड नहीं चलता. अब नॉन सिंपल कौन सी स्पेसेस हैं? नॉन सिंपल हो सकती हैं वो जो या तो इनफाइनाइट है, ठीक है. अगर इनफाइनाइट हो गई तो सिंपल नहीं रही, या फिर वो इक्वी लाइकली अगर नहीं है, यानी इफ इट इज़ नॉन इक्वी लाइकली, राइट, इफ इट इज़ नॉन इक्वी लाइकली. ओके, ये हम पिछले लेक्चर्स में देख चुके हैं बात. तो आज का लेक्चर इस चीज़ पे है कि नॉन सिंपल सैम्पल स्पेसेस पे प्रोबेबिलिटी कैसे कंप्यूट की जा सकती है. सबसे पहले देखते हैं कंप्यूटिंग प्रोबेबिलिटी वाया लेंथ. ठीक है, लेट्स से यू हैव अ सैम्पल स्पेस. अब नोटिस कि मैं किस तरह की नोटेशन यूज़ कर रहा हूँ. मैं स्क्वायर ब्रैकेट्स लगाए हैं, 0,4. व्हाट डज दिस कॉरस्पॉन्ड टू? इसका मतलब है ऑल रियल नंबर्स फ्रॉम 0 till 4. ठीक है, और 0 और 4 दोनों इंक्लूडेड हैं इसमें. ठीक है, बोथ इंक्लूडेड. ठीक है, ये स्क्वायर ब्रैकेट का ये मतलब है कि ओपनिंग वाले स्क्वायर ब्रैकेट का मतलब है कि ये जो लोअर लिमिट है 0 ये इंक्लूडेड है, और क्लोज्ड राइट साइड वाले क्लोजिंग स्क्वायर ब्रैकेट का मतलब है कि जो अपर लिमिट है 4 दैट इज़ ऑल्सो इंक्लूडेड. अगर इंक्लूड ना करने होते तो हम ऐसे कहते 0 और 4. अब ये इंक्लूडेड नहीं है. अगर हमने 0 इंक्लूड करना होता और 4 इंक्लूड ना करना होता तो ऐसे लिखते. अगर 0 से बड़े नंबर्स चाहिए होते और 4 इंक्लूडेड होता तो ऐसे लिखते. तो आई होप ये नोटेशन आप समझ गए होंगे. स्क्वायर ब्रैकेट का मतलब है कि ये नंबर इंक्लूडेड है. ओपन ब्रैकेट का मतलब है कि इसके या आगे या इसके पीछे, सॉरी पैरेंथेसिस, जो नॉर्मल पैरेंथेसिस है उसका ये मतलब है. ओके फाइन. तो ये हमारी सैम्पल स्पेस है. इस सैम्पल स्पेस का साइज क्या है? एनीवन?
इनफिनिट.
एक्चुअली सर,
जी जी
ये थर्ड जो आपने लिखा है 0 and 4
जी.
और ये ब्रैकेट्स, इसको जरा चेंज कीजिएगा. ये क्या, इसका मतलब क्या बोला? थर्ड वाले का
कि 0 नहीं इंक्लूडेड और 4 इंक्लूडेड है.
मतलब जो स्टार्ट होगा वो 0.1 से स्टार्ट होगा.
नहीं, 0 पॉइंट, आप कोई भी स्टार्टिंग मुझे पॉइंट नहीं बता सकते. बस ये होगा कि 0 से जो भी बड़ा नंबर होगा वो इस सैम्पल स्पेस में आएगा, बस 0 नहीं होगा.
यस सर.
ओके ग्रेट. इस सैम्पल स्पेस में अगर मैं कहूँ कि ये नंबर ऑफ नंबर्स कितने हैं, अमाउंट ऑफ नंबर्स कितने हैं, वो इन्फिनिट है. ठीक है, क्योंकि सारे रियल नंबर्स हैं. इसका मतलब मैं काउंटिंग यहाँ पे नहीं कर सकता. ये जो स्पेस मैंने बनाई है ये इनफाइनाइट भी है, लेकिन इसकी अच्छी बात यह है कि ये बाउंडेड है. इसकी लिमिट्स जो हैं वो 0 और 4 है. इट्स अ बाउंडेड, इट्स इन्फिनिट, इट्स बाउंडेड. और मैं आपसे ये भी कह देता हूँ कि ये इक्विलाइकली स्पेस बनाई है मैंने। अभी इसकी प्रोबेबिलिटी से मैंने बताई नहीं, लेकिन मैं को पहले से बताता हूँ कि इक्विलाइकली है। पर लेट्स सी उसका क्या मतलब होगा यहाँ पे। इस स्पेस को हम ऐसे भी देख सकते हैं कि ये एक लाइन है जो जिसके यहाँ पे 0 है, यहाँ पे 4 है, I don't know, 1 2 3 4। सो यहाँ पे 1 है, यहाँ पे कहीं 2.5 होगा, ठीक है, ये 2 है, ये 3 है, ओके। मैं आपको एक इवेंट इसमें देता हूँ, इवेंट ए, या एक सबसेट देता हूँ ए, और सबसेट ऐसे डिफाइन कर रहा हूँ। कोई मुझे समझा सकता है इसमें कौन से नंबर्स हैं? एनीवन?
सर 1 से लेकर 2.5
वन है, एंडिंग है 2.5।
और ये इंक्लूड हो रहे होंगे दोनों या नहीं?
यस सर।
ठीक है। सो इज द event that selected point is in this set, okay। प्रोबेबिलिटी ऑफ ए निकाल सकते हैं आप? कैसे निकालें? हमें एक जनरल रूल पता है। जनरल रूल ये है, साइज ऑफ ए ओवर साइज ऑफ एस। लेकिन हम पहले साइज को काउंटिंग से करते थे, आज हम काउंटिंग नहीं कर सकते। पिछली दफ़ा हमने एक एग्जांपल की थी, वो भी इनफाइनाइट स्पेस थी, लेकिन काउंटेबली इनफाइनाइट, और उसमें हमने सम से की थी। आज किस तरह से हम, कैन यू कम अप विद अ वे जिस पे हम साइज डिफाइन कर लें ए का और एस का? एनीवन?
सर लेंथ के थ्रू
जी, दो आंसर आए हैं। पहला आंसर क्या था? एक आंसर सम है, पहले क्या किसी ने कहा था? लेंथ। एग्जैक्टली, दैट्स अ गुड आइडिया। यानी लेट्स ट्राई लेंथ ऑफ ए, हम डिफाइन ही ऐसे कर लेते हैं साइज को, डिवाइडेड बाय लेंथ ऑफ एस। ये इसलिए कह रहे हैं क्योंकि ये बाउंडेड थी, सैम्पल स्पेस हमारी बाउंडेड थी। इसका मतलब है इसका कोई मेजर होगा इसका लेंथ का या इसके साइज, क्योंकि बाउंडेड है, ये इन्फिनिटली बड़ी नहीं है। नंबर ऑफ एलिमेंट्स की बात करें इन्फिनिटली बड़ी है, लेकिन अगर इसके एक्सटेंट की, इसके एरिया, इसके लेंथ की बात करें, इसकी लिमिट्स की बात करें, वो बाउंडेड है, लिमिटलेस नहीं है। तो लेंथ ऑफ एस कैसे डिफाइन करें? लेंथ ऑफ एस आप डिफाइन कर सकते हैं?
2.5।
एस लेंथ ऑफ
4 सर।
4 कैसे डिफाइन कैसे की? 4 कैसे आया?
0 to 4
यानी 4 हाँ मैक्सिमम, यानी हाँ अपर लिमिट माइनस लोअर लिमिट, जो भी, अगर लिमिट अगर लेट्स से 0 ना होती 1 होती लोअर, तो 4 - 1 आ जाता, जो भी है, ये दैट्स द लेंथ। तो इसी रूल के मुताबिक ए की लेंथ क्या आ गई?
1.5।
2.5 - 1, अपर लिमिट माइनस लोअर लिमिट, and that gives you 1.5 over 4, which is equal to 0.375। अब हम कैसे मान जाएं कि ये जिस तरह से आपने लेंथ के तरीके से डिफाइन कर दी प्रोबेबिलिटी, कि ये प्रोबेबिलिटी के रूल्स फॉलो करेगी? अभी तो प्रोबेबिलिटी 0 और 1 के बीच में आ गई है, क्या पता ये तुक्का लग गया हो। क्या ये हमेशा ऐसे होगा? ओके, सो जी, कैन एनीवन आंसर, क्या ये इस तरीके से कंप्यूट की हुई प्रोबेबिलिटी विल इट ऑलवेज बी बिटवीन 0 and 1?
यस सर।
व्हाई?
सर वो आपने ऊपर बता दिया कि इक्विलाइकली है, तो
नहीं,
सर क्योंकि सैंपल हमेशा बड़ा होगा इवेंट से।
probability of A will always be between 0 and 1 since length of A will always be either greater than or equal to 0, है ना? कोई सबसेट आप बना सकते हैं ऐसा जिसकी लेंथ नेगेटिव हो?
नो सर।
तो इसका मतलब लेंथ 0 होगी या 0 से बड़ी होगी, एंड लेंथ ऑफ ए विल ऑलवेज बी लेस देन इक्वल टू लेंथ ऑफ एस, है ना? ये दोनों बातें सच है ना?
यस सर।
फॉर एनी सबसेट, मैं लिख देता हूँ, फॉर एनी सबसेट ए, चलिए ऐसे भी लिख देता हूँ, ए बिलोंगिंग टू एस। तो देयरफॉर ये जो आपने लेंथ के तरीके से ये फॉर्मूला खुद ही बना लिया, खुद ही हमने डिफाइन कर लिया, ये जब हम कर रहे थे तब हमें नहीं पता था कि ये प्रोबेबिलिटी के रूल्स फॉलो करेगा या नहीं करेगा, बट वी हैव जस्ट चेक्ड ये सारे रूल्स फॉलो करता है। इसकी बेस पे किसी भी सबसेट की प्रोबेबिलिटी 0 और 1 के बीच में आती है। देयरफॉर दिस इज अ गुड डेफिनेशन, दिस कैन वर्क एज अ वे ऑफ कंप्यूटिंग प्रोबेबिलिटी। ओके, जी
सर ये जो हमने लिखा है लेंथ ऑफ ए, तो हमने तो 0 इंक्लूड किया था, तो हमने 2.5 माइनस 1 क्यों किया, 0 क्यों नहीं किया?
ए की मुझे अपर और लोअर लिमिट बता दें बस। ये आपका सेट ए है यहाँ पे, इसकी अपर और लोअर लिमिट मुझे बता दें।
Okay, thank you. Sorry.
Okay, no problem. Oh, by the way, मैं फिर से उर्दू बोल रहा हूँ। So let's switch to English. Is Abdul Haq present? Abdul Haq, are you there?
Yes, I am. No problem, inshallah, I can check for this too.
Did you understand the lecture so far?
Yes, sir, yes.
Okay, whenever you don't understand, just let me know.
Okay, sir.
And are you okay if I continue in Urdu?
Yes, inshallah.
Inshallah can mean many things. So I'll just continue in a mix of both. And so whenever you have a problem, just stop me and I'll immediately switch solely to English and try to explain. Okay?
Okay, sir.
All right. Okay. Can you guys tell me if A equals, I'm making a set. The set A contains 3 and 3, right? Which means all numbers starting from 3 and ending at 3. So how many numbers will it have?
Infinite, sir.
Are you sure?
All real numbers.
All real numbers starting from 3 and ending at 3.
Both included.
You'll only have 3, that's it. It only contains 3 because the lower limit and upper limit are the same. So there's nowhere to go, it just contains 3. Now I ask you, what is the probability of A? Can anyone tell me? Use the same formula, length of A. Can anyone tell me the probability? You might have guessed it now.
0.
Yes, it's 3 minus 3 over 4 minus 0, which is 0 over 4, which is 0. So the probability of any event will be proportional to the length of the event. If the length of the event is 0, then the probability will be 0. All right? We will encounter this later in the course as well. This idea that whenever the length is 0, whenever the measure whenever the measurement is 0, probability will be 0. Okay. Okay, now let's do another thing. Now we compute probability via area. Okay. Let's assume that you have a circle. Yeah.
सर लेकिन जब हम लोग वैसे सोलली अगर 3 की प्रोबेबिलिटी देखें इस पूरे रियल नंबर से सेट में, सर वो तो 0 नहीं होगी ना, ये अगर हम लेंथ से निकाली। सर जैसे फॉर एग्जांपल अगर हमारे पास इंटीजर्स का सेट है तो 3 आने की प्रोबेबिलिटी कुछ ना कुछ तो होगी।
When you have the set of integers, is it I mean, see, we are talking about uncountably infinite spaces. I mean, this one is uncountable. This is uncountable. With integers, you have a countable set, which might be infinite, but it's countably infinite. And for countably infinite spaces, we covered that in the last lecture, right?
यस सर।
Okay.
लेकिन सर फिर भी रियल नंबर्स में भी 3 तो एग्जिस्ट करता ही है।
I'm not saying that.
नहीं आ रही।
Yes, I'm not saying that 3 does not exist, but this definition that you used. See, okay. It's just that we have defined it this way. If you want to define probability and if you want to come up with another formula, go ahead. But if you use length to define probability, you're stuck with this. आपको कहीं ना कहीं सजदा करना पड़ेगा। अगर आपने लेंथ से प्रोबेबिलिटी निकालनी है तो लेंथ जब भी 0 आएगी प्रोबेबिलिटी 0 आएगी, फिर आपको माननी पड़ेगी ये बात। इफ यू डोंट लाइक दिस, come up with another way of finding size. Do you understand? I mean, I can sympathize with your confusion. Oh, how can something have probability 0? Well, if you define probability by length, then whenever length is 0, probability will be 0, and you have to live with this. ठीक है?
Yes, sir. Sir, is there any way to compute probability?
Maybe there is. Maybe you can make one. But generally, that's how it is used. This is a standard way of working with probability. If length is 0, if size is 0, probability is 0. If you want to change your definition of size, go ahead. As long as you're consistent with all the axioms and all the rules. Okay, now we're going to cover probability via area. So you have a circle, and the radius of the circle is 3. And within the circle, you have a square, and the square has side 2. Okay. Let me call this part A, and let me call the whole circle the sample space S. Okay, now this sample space S, which is the circle. Okay, this sample space, is it bounded? Is S bounded?
Yes, sir.
Yeah, it's bounded. Is it, how many points does it have? S. How many points does it have?
Infinite.
Infinite, because when I say points, it means all real numbers that lie within this circle. Well, there are infinite real numbers. If there are infinite real numbers in such a small space, if there are infinite real numbers between 0 and 4, then of course there will be infinite numbers within a circle as well. Okay, so it's infinite. There are infinite points, and let's say this is equilikely as well. We probably don't need this information right now, but let's say it's equilikely. Can you find the probability of A? Anyone? Can you guys help me out? I'll help you by giving you the general formula: size of A over size of S. Can you define probability of A?
We can define size as area.
We can define size as area. So what's the probability then? Quickly.
सर एरिया एक जो है हमारे पास स्क्वायर में आ रहा है तो स्क्वायर का एरिया हो जाएगा हमारे पास आर का स्क्वायर यानी कि दोनों का स्क्वायर हो जाएगा लेंथ इनटू लेंथ और एस हमारे पास सैंपल स्पेस और वो सर्कल है तो सर्कल का हमारे पास एरिया होता है पाई आर स्क्वायर तो ऐसे हम कंप्यूट करेंगे शायद प्रोबेबिलिटी.
So is it 4 over 9 pi? Am I correct?
Yes sir.
Yes, sir.
Yes, sir.
Right? 2 into 2.
Yes, sir.
2 into 2 over pi r square, and r was 3. That's 9 pi. And this comes out to be 0.141. And you don't have to compute this final answer. If you give me 4 over 9 pi, I'll be happy. And you'll get full marks. As long as you can verify that the answer is between 0 and 1. So when you define it by area, when you define it by area, is it ensured that for any event A, probability would be between 0 and 1? For any subset of S. Why? So? So?
Sir, A हमेशा से अंदर ही गाइड करेगा तो S से छोटी ही होगी.
Yeah, since and will area be negative? Area can never be negative, right? Yeah. So area will be greater than 0 and area of A will be less than equal to area of S. Therefore, probability computed through areas will always be between 0 and 1 as long as A is a subset of S.
अगर हमारे पास सब सैंपल स्पेस ही सर्कल में अगर सैंपल स्पेस को एरिया एंगुलर पैटर्न में हो सके तो उसका एरिया कैसे सैंपल स्पेस कैसे निकालेंगे?
इस तरह
यस सर कोई कुछ भी हो तो इसी तरह करेंगे.
ठीक है. Even then, probability of A equals area of this shape, whatever the shape is, divided by area of shape, whatever the shape was, I don't know, divided by area of this other shape. Now the question is how to compute these areas. Okay, now computing areas, there are different methods of computing areas. Okay, and some are simple, some are really complicated. Let's not go into these complicated details. In your calculus course, you learn very fancy ways of computing areas. Okay, you learn proper ways of computing areas in your calculus course. Okay, when you study integration. So I don't want to go there right now. इजाजत है?
यानी कि हमारे इस कोर्स में इससे रिलेटेड कोई क्वेश्चन या कुछ भी हम पढ़ेंगे नहीं.
For any question that I give you in this course, the area will be computable, easily computable, using methods that are known to you. So don't worry.
Okay, sir.
But you should know the general idea. Right? For example, if I give you a multiple choice question like this, you should be able to at least give me this expression. Even if you can't come up with the number, you can at least give me this expression. Okay, you should know the general idea. Okay. Now notice the first sample space was in 1D which was 0 to 4. Just one dimensional. The second sample space that we covered, the circle, that was in 2D. It was two dimensional, right? It was a circle. That's two dimensional. This was a line. That's one dimensional. In one dimension, you measured size by length. In two dimensions, you measured size by area. In three dimensions, you will measure size by what?
Volume.
Yes, you will measure size by volume. And in higher dimensions, you will still measure size by volume, but we'll call it hypervolume. Because we can't imagine more than 3 dimensions. So it's just volume, and we call it hypervolume. And what you call volume, isn't it just a generalization of area? And what you call area is just a generalization of length, right? So it's the same concept. Really, the real concept here is measurement. In 1D, when you measure things, you get length. In 2 dimension, when you measure things, you get area. In 3D, when you measure things, you get volume. In higher dimensions, when you measure things, you get hypervolumes. Okay. So really what...
हमारे कोर्स में कौन सी है 3D तक है
guys, stop worrying about course and questions and exams and syllabus and out of course, and stop worrying about this stuff. Worry about knowledge. So really what we've covered so far in this lecture has been probability via measurement. In 1D, this measurement takes the form of length. In 2D, it takes the form of area. In 3D, it takes the form of volume, and so on. That's what we've covered so far in today's lecture. Okay. So you start measuring when you can't count. Okay. You start measuring when you can't have sums. You start measuring in uncountably infinite sample spaces. Okay. Now let's quickly I don't know if we will be able to cover this, but let's quickly do a problem. I'll try to be quick. There are two people, Zaid and Khalid. They agreed to meet at a park between 3 p.m. and 4 p.m. Okay. Both decided not to wait for the other person more than 10 minutes. What does that mean? If Zaid comes at 3, till what time will he wait for Khalid? Anyone?
3:10.
3:10. 3:10 he goes back. Okay. Both Zaid and Khalid, they arrive at the park independently of each other. Okay. Zaid doesn't know when Khalid is going to come. Khalid doesn't know when Zaid is going to come. They just arrive independently of each other. Okay. At random times, they arrive independently of each other at random times between 3 and 4 p.m. So it's guaranteed that both will arrive between 3 and 4, but we don't know when. But both of them will arrive. That's given. It will happen. Now I'm asking you to give me the probability that they will meet. What is the probability that they will meet? Okay. So, is my experiment random? Yes, my experiment is random because both persons arrive at random times. Once the experiment is done, I will have the arrival times of both persons, which means my sample space should look like the set of all pairs of arrival times. All pairs of possible arrival times. That's my sample space, the set of all possible pairs of arrival times. But they will be pairs. For example, if Zaid arrives at time 0 at 3 p.m. and Khalid arrives at 4 p.m., will they meet?
नहीं सर.
No.
But is it possible that Zaid arrives at 3 and Khalid arrives at 4? Is it possible?
Yes.
So it means that that should be in my sample space. It's not in my event space, but it's in my sample space. Can we draw the sample space somehow?
दो ट्यूपल्स होंगे शायद इसमें सैंपल स्पेस में.
Yes, that's true. Let Z be Zaid's arrival time.
सर बिटवीन का मतलब ये नहीं है कि 3 और 4 हमारे उसमें इंक्लूडेड नहीं होंगे सैंपल में.
Yeah, but let's include them. I mean, we can be specific here, but it's included. Okay. So, for example, if someone comes at 3 hours and 0.0000001 seconds, I mean, Zad's gonna count that as 3, right? So let's not be that specific. Let K be Khalid's arrival time. Then your sample space can be modeled or it can be visualized like this. You could have, what can be Zayad's arrival time? He can arrive at 0 minutes after 3, or he could arrive maximum at 60 minutes after 3, right? So Z, this variable Z that I made, Zayad's arrival time, it could be between 0 and 60 minutes after 3 p.m. Let's also have Khalid's arrival time. It could be between 0 and 60 minutes after 4. What will be this point? Can anyone tell me what's this point? What does this mean?
So 4 p.m.
दोनों 4 बजे पहुंचे.
Yes, this means
both arrived.
Zaid arrived at 60 minutes, and Khalid arrived at 60 minutes. Okay, great. Okay, 10, 15. What would this point mean? Anyone?
50-50.
Then arrived 59.
Is it 50-50? 50 and 60. So Zaid arrived at 50 minutes and Khalid arrived at 60 minutes. And will they meet? Will they meet?
Yes.
So let me draw this in blue. 50 and 60. So they meet because the difference is only 10 minutes. What will be this point? Anyone?
50 and 20.
Yes. So Zaid arrived at 50 minutes and Khalid arrived at 20 minutes. Will they meet?
No.
Okay. Let me just write this down for reference. Zaid arrived 50 minutes. 50 minutes after 3 p.m. and Khalid arrived 20 minutes after 3 p.m. So they will not meet because the difference of their arrival times is more than 10. Great. So we just have to find those points which ensure that they will meet. Okay.
ऐसे पॉइंट में अपर और लोअर लिमिट का फर्क 10 या 10 से कम हो.
Yeah. Let me draw a line. Can you tell me what this line represents? Oh wait, let me change the color. Can you tell me what this diagonal line will represent? This blue diagonal line? Anyone?
No.
Both arrive at the same time. So definitely they'll meet. Okay. Now consider this region, this green region. What does this tell you? What does this tell you? So all times on the green line, for all times on the green line, who arrived first?
Zaid.
Zaid arrived at 50 minutes and Khalid arrived after 50 minutes on the green line. But the maximum difference of their times would be what on the green line?
10.
10. So they will meet. Any point on the green line means they're going to meet. Agreed? So, do you understand the blue line? Blue line की समझ है आपको?
Yes, sir.
ब्लू लाइन का मतलब है कि दोनों एक टाइम पे आए. लेकिन ब्लू लाइन पे मैं 50 वाली जगह पे आता हूँ और मैं ऊपर एक ग्रीन लाइन ड्रॉ की है और लेट्स से ग्रीन लाइन पे कोई पॉइंट आप ले लें. ग्रीन लाइन पे कोई भी पॉइंट आप ले लें, इसका मतलब है कि जैद 50 मिनट्स पे आया था. ग्रीन लाइन पे कहीं भी आ जाएं आप, जैद 50 मिनट्स पे आया था. और but Khalid arrived after Zaid. But Khalid can arrive maximum at 60. तो तो वो 60 से पहले आ गया था या 60 तक आया होगा. इन एनी केस दे विल मीट, क्योंकि उनके अराइवल टाइम्स का डिफरेंस इज लेस देन इक्वल टू 10.
फिर
सिमिलरली
खालिद बाद में आएगा, ये कैसे कह रहे हैं आप?
बिकॉज जैद का अराइवल टाइम ये
50 है.
50, या ये जैद का अराइवल टाइम है.
वो खालिद भी तो 50 पे आ सकता है.
आया होगा, लेकिन अगर 50 पे आया तो ये लाइन के ऊपर है. इफ ही अराइव्स एट 51 इट विल बी दिस पॉइंट, 52 दिस पॉइंट, 53 दिस पॉइंट, 54 दिस पॉइंट, 55 दिस पॉइंट. इट विल कीप गोइंग अप खालिद अराइवल टाइम.
ओके सर.
कि ऊपर छोटी सी ट्रायंगल बनी है उस तरह नीचे भी छोटी सी बनेगी, तो वो भी यही चीज होगी.
एग्जैक्टली. सो व्हाट डज दिस रिप्रेजेंट? So what I'm trying to draw is, what does this whole length represent? All points on this green line, what do they represent? And let me draw the let me draw this point as well. Oh yeah. What's this point? What's this point?
40.
This is 50. Zaid arrives at 50 and Khalid arrives at 40. The difference is 10. They will meet, and all along this line the difference will first it will decrease to 0 and then it will go back up to 10. All across this line the difference is always going to be less than equal to 10. What about this point? Won't we have a similar line over here covering 10-minute differences, and over here covering 10-minute differences? All these green lines that I'm drawing contain points where they will meet. In fact, what will be this point? Can anyone give me this point? What is this? And what will be this? Anyone? 10 0. How do I know? I didn't know about 10. I knew about 0. Why 0? Because this point is touching the x-axis. It means Khalid arrived at 0. But if Khalid arrived at 0 and they met, it means that Zaid must have arrived maximum at 10 minutes, not later. What would be this point? The upper point. ये कौन सा point होगा? Zaid arrived at 10,20. 10,30 they will not meet because the difference has to be 10 minutes. They will meet. So let me draw this line again then. Really what you'll have is this. And you will have something like this. All points within this region, all points within this region oops. Yeah, all points within this purple region, they will represent arrival times, pairs of arrival times when they will meet. So I'll okay. So purple region represents all pairs of arrival times. Purple region represents all pairs of arrival times for which Zaid and Khalid will meet. Okay, and so that's your event. That's your event. Let's call your event E. That's your event E. What's the sample space? Or can you give me, okay, what's the sample space in this figure?
3600.
No, you're giving the answer to my next question. But what is the sample space in this figure?
The whole area under the ground.
एरिया पर्पल जो आपने किया वो सारा आपका एरिया
जी बिल्कुल, ये पूरे का पूरा पर्पल का एरिया। इस पर्पल का एरिया तो नहीं होगा, सैंपल स्पेस तो ये नहीं है।
It is square.
The whole square, the whole square is the sample space.
का एरिया ये
Okay, all right.
तो
So
हमारा इवेंट होगा
the whole square of all possible pairs of arrival times. So what's the probability then? Probability of meeting. Probability of meeting equals what?
Area of Indian region.
Size of E over size of S, which is equal to area of E divided by area of S. Now let's see how smart you guys are in computing areas.
सर इनमें से दोनों ट्रायंगल माइनस कर दे तो वो आ जाएगा
Yes, that's a smart strategy. So you're saying that the purple region is just the whole square minus these two triangles, right? There's this upper triangle here and there's a lower triangle here, and if I subtract the areas of these two triangles from the area of the square, I'll get the purple region. Okay, so the area of the sample space is 60 into 60, that's 3600. And so you're saying that use the area of the sample space, 3600, minus the area of the two triangles. And what will that be? Half base into height. Anyone? What's the base? What's the height of one triangle? Half. So the base is 50, the height is also 50, but that's true for both triangles. Both triangles have height 50, base 50, and so I do 2 times this, and what I'll get is 3600 minus 2500 over 3600, and you get I think 1100 over 3600, and so the probability comes out to be 11 over 36, and that's the answer. So it's like 11 over 36 is a little less than 1 over 3. Okay, it's a little less than 30% chance, or 33%, 30, yeah, something like that. Okay, so now we've looked at how to compute probability in सैम्पल स्पेसेस वेयर यू कांट काउंट, यानी हमने मेजरमेंट के साथ प्रोबेबिलिटी कंप्यूट करना सीखा है। यानी हमने एक ये वाली स्पेस 0 से 4, लेकिन इन्फिनिट अमाउंट ऑफ नंबर्स थे इसके अंदर, लेकिन बाउंडेड थी। ओके, सो दिस वन वाज बाउंडेड बट इनफाइनाइट स्पेस थी। फिर हमने सर्कुलर सैम्पल स्पेस देखी और वो भी लेकिन बाउंडेड थी, बाउंडेड येट इनफाइनाइट। फिर हमने ये मीटिंग प्रॉब्लम देखी जैद और खालिद के मिलने की, और उसकी भी जो सैम्पल स्पेस थी वो बाउंडेड थी, बाउंडेड बाय दिस स्क्वायर, और उसमें मीटिंग टाइम्स जो थे वो इन्फिनिटली ज़्यादा थे। तो ये सब केसेस में जो फ़िलहाल हमने देखे हैं इनमें इन्फिनिट सैम्पल स्पेसेस थी, लेकिन इन्फिनिटली लार्ज सैम्पल स्पेसेस थी, लेकिन सारी की सारी बाउंडेड थी। तो इसलिए हम इसमें मेजरमेंट कर ली। इसमें हमने लेंथ से साइज़ मालूम कर लिया, इसमें एरिया से, और इसमें भी एरिया से। अब हम इसी सैम्पल स्पेस पे काम करने लगे हैं। ठीक है, यानी मेरी जो सैम्पल स्पेस है वो 0 से 4 के बीच में तमाम नंबर्स हैं, लेकिन the chances of a number increase as we move away from 0 and towards 4। यानी 0 के पास से नंबर आने के चांसेस कम है और 4 के पास से नंबर सेलेक्ट होने के चांसेस ज़्यादा हैं, which means कि now we are dealing with bounded, infinite, क्योंकि सारे रियल नंबर्स हैं, इन्फिनिटली ज़्यादा हैं, but non-equilikely sample space। ठीक है, 4 के पास नंबर, जितना नंबर बड़ा है 4 के पास है उतना चांस ज़्यादा है उसका, जितना नंबर छोटा है 0 के पास उतना उसका चांस कम है सेलेक्ट होने का। सैम्पल स्पेस। ओके, और ये जो चांसेस हैं वो मैं आपको बता देता हूं कि वो चांसेस कैसे आ रहे हैं। चांसेस इस किस्म के हैं, ये आपका एक्स एक्सिस है, ये आपका 0 वाला पॉइंट है, ये आपका 4 वाला पॉइंट है, 1 2 3। ओके, और मैं कहता हूँ कि जो चांसेस हैं चांसेस भी नहीं, थोड़ी देर के लिए आप ज़रा प्रोबेबिलिटी को भूल जाएं। ठीक है, प्रोबेबिलिटी को थोड़ी देर के लिए भूल जाएं। मेरे पास एक्स एक्सिस है, एक्स एक्सिस पे मैंने 0 से लेके 4 तक मेरे पॉइंट्स हैं, और मैं एक फंक्शन ड्रॉ करने लगा हूँ, और वो ये वाला फंक्शन है। ठीक है, और इस फंक्शन की मैं आपको फॉर्म बता देता हूँ। ये फंक्शन है f of x equals x square। ठीक है, जब जब x 0 है तो 0 का स्क्वायर 0, जब x 1 है तो यू हैव f ऑफ 1 विच इज़ 1 का स्क्वायर 1 आ गया, 2 पे 4, 3 पे 9, 4 पे 16। तो ये क्वाड्रेटिक फंक्शन है, इससे क्वाड्रेटिक फंक्शन ये इस तरह करके ग्रो करता है। और मैंने बस एक 0 से लेके 4 तक एक क्वाड्रेटिक फंक्शन ड्रॉ किया है, एफ ऑफ एक्स इक्वल्स एक्स स्क्वायर या वाई इक्वल्स एक्स स्क्वायर। फाइन, ओके, नाउ रिमेंबर, अब मैं वापस प्रोबेबिलिटी पे आने लगा हूँ। ये मेरी सैम्पल स्पेस है, ठीक है, जो कि इन्फिनिटली लार्ज है, बाउंडेड है, पर इसमें चांसेस जो हैं वो बराबर नहीं है चीज़ों के। और वो जो नॉन इक्विलाइकली जो फैक्टर है वो ये कर्व ही वो नॉन इक्विलाइकली चीज़ों को शो कर रहा है। हम ये कह रहे थे कि चांसेस ऑफ अ नंबर इंक्रीज एज वी मूव टूवर्ड्स 4, तो दिस फंक्शन ऑल्सो इंक्रीजेज एज वी मूव टूवर्ड्स 4, ठीक है, and this function decreases as we move towards 0, and we said that the chances of numbers should decrease as they move towards 0. So this function seems to be representing our condition for chances, that lower numbers should have lower chances and higher numbers should have higher chances. Let's keep going. Do you guys remember that when we looked at this sample space, s equals 1, 2, 3, all positive integers, and we said that this space was unbounded and it was infinite, and we couldn't decide how to compute the size of the sample space, so we had a trick. We assigned numbers to each of these elements, but the numbers that we assigned were smaller and smaller and smaller and smaller, right? Progressively smaller, and if the numbers become smaller and smaller, when you sum those numbers they add up to a certain value which is less than infinity, and so we used this trick to come up with the size of s, and the size of s was the sum of these numbers. Which came out to be 2 in this case, and since now because of this trick we had the size of s, we could find the size of any subset of s as well, and then we could find probability of any subset of this sample space. So that's the trick that we played, and if you want to name this trick, we artificially assigned numbers to elements of s. Okay, we're going to play the same trick over here. In fact, we have already played the same trick over here. To each element of s, we will assign to each element, let's call it x, we will assign f of x. Okay, so 0 gets f of 0, which is 0. 0.1 gets f of 0.1, which is 0.01. So there'll be many numbers. I can't, there'll be infinite numbers, so I can't write all of them down, but so 2 will get f of 2, which is 4, which is 4, and you get the idea, right? Any number x will get f of x. So we're going to artificially assign some numbers to elements of the sample space. And in this way, what we will end up doing is that we will artificially assign an area to S. And what will that area be? Let me copy this. We will assign an area to S. And that area will look like and that's the area. The whole area under this curve, the curve f of x equals x squared, the whole area under this curve but above the x-axis, and going from 0 till 4, this blue shaded area, I am going to define, artificially assign this area as the size of my sample space. Size of S equals this area. And let's be more specific. The area under the curve, and what's my curve? It's defined as f of x equals x squared, from 0 till 4, right? And for those of you that have studied integration, area under the curve, you can write it using some notation from calculus. It's written like this: lower limit 0, upper limit 4. This is called the integration sign. Let's call it the integration sign. It just means whenever you see this elongated S, what this means is that we are going to compute the area under some curve. Which curve? That curve is written over here. And you use this notation. Let's ignore this notation for now. This is just if we are speaking math instead of English, That's how we will say, that's how this sentence translates. In English, you say it like this. In math, you say the same thing like this. See, mathematics is a language. It really is. So all I've done is I've translated this sentence from English to mathematics. Okay. Don't worry if you don't know how to solve this. Don't worry about it. Okay. You will study these things in a calculus course. Most of you might have already studied integration, and most of you might already know how to compute this. Some of you might not. But in your calculus course, you will study how to compute areas under graphs or under curves and under functions. But for now, let's just borrow this notation. In this course, I will not ask you to compute such areas. I will not ask you to compute such areas. But you should know this notation at the very least. That this notation means you're computing the area under the curve x square from 0 till 4. Okay. All right. Okay, knowing this. Okay, let me bring this down. Knowing this, you might now, you might have already noticed how I could assign, look, this is your sample space S. I want a new event, and the event is A, and that means the event A is that I pick a number between 3 and 4, both included. Okay. How would I compute the size of this event? Some of you might have guessed that just like we define the size of the sample space, we can now define the size of any subset of S, and that would be the area from 3 till 4 under the curve x square. Let's just keep this notation as well. Okay, let me translate it in English. Is the area under the function x square from 3 till 4. Okay, and let's draw it. This is the area from 3 till 4. The green shaded area. Okay. And this gives you a way of computing the probability of any subset of A, any subset of S. Right? Probability of A equals size of A over size of S, which is equal to area of A divided by area of S, which is equal to area under the curve x square from 3 till 4 divided by area under the curve x square from 0 till 4, the lower and upper limits. And in fact, what we've really done is, it's like, what we've done is, since these areas, since this area was artificially assigned, it was artificially assigned. Why? Because we decided we're going to put the function f of x equals x square. What if I had decided, no, I'm going to put the function g of x equals x to the power 4? What if I had decided this way, right? So then you would have gotten different areas. So because it is us that is assigning, it is us that are assigning these areas, you can also say that we have used something called generalized area of A divided by generalized area of S. Because truly, look, S was like this. S went from 0 till 4. And you could argue, look, you have S in your hand, just use length. But we didn't. Because if we used length, then we would have gotten equilikely, we would have obtained an equilikely sample space. But we wanted a non-equilikely sample space, which is why we artificially introduced this curve and then artificially introduced this area and then used this area, a generalized area, to find the size of S, or to define the size of S. So this is one trick. This is one trick to find probabilities or to make non-equilikely sample spaces and then find probabilities in them. Now you will notice, and I can leave this for you. If I define the set A1 from 0 till 1, and I define another set A2 from 3 till 4, which we just did, the green area, right? In terms of length of A1 equals 1 minus 0, which is 1, and length of A2 is 4 minus 3, which is again 1. So both subsets A1 and A2 have the same length, which means they will have the same probability. If I was defining probability using length, if I was defining size using length, both of them would have had the same chances, same probability. And that's what we mean by an equilikely sample space. But when we came up with this generalized area, then generalized area of A1 would be this small triangular region, right? If this is 4, if this is 0, this is 1, 2, 3. This small region, that's the area. And the generalized area here of A2, we've already seen this. That's this area from 3 till 4. And this is much larger. Okay. And that starts giving you a non-equilikely sample space. For those of you, by the way, for those of you that know integration and are concerned with what the answer might be, this answer comes out to be 37 over 64, which comes out to be 0.5781. Don't worry about this. I will not ask you. I will not ask you such questions. I mean, I will not ask you to solve such questions, but I might ask you how you can compute probabilities. Okay, you might not need to compute the final answer, but you should know the method.